Hey guys, I'm back with another project. This is a functioning radiator for car that I built with what I had in my shelf. This basically displays the coolant temperature of the engine while the system controls the speed of the fan accordingly. So, without any further ado, let's dive in. This time I'm using an I2C based OLED display, which is the only display I got left on my shelf. An Arduino Nano to control the overall process, a fan to lower the coolant temperature, which is then controlled by a transistor, and a buzzer to indicate a high temperature warning, and a push button to start the system, and finally a relay to control power to the overall circuit. Okay, let's hook it up to the power supply. Here we go. Let's turn this on. You can see a warning sign blinking on top left of the display. This means either the temperature sensor is malfunctioning or it has been disconnected. In this case, I have removed the sensor from the breadboard. So that's why there's a warning sign. For measuring the coolant temperature, we're gonna use the DS18B20 temperature sensor, which communicates to the one-wire protocol. Let me connect it real quick. Now you can see that the warning sign has disappeared. The readings of the temperature sensor are shown here. I have programmed the Arduino to open the gate only if the coolant temperature hits 30 degrees Celsius. So once the DSB1820 hits 30 degrees Celsius, the fan will start to run automatically. Let me quickly raise the temperature with my hairdryer. Here we go. By the way guys, the program's temperature threshold is scaled down so that I could demonstrate the working under lower temperature. As you can see, the fan speed increases as the current temperature increases. Let's raise it all the way up to 36 degrees Celsius. Once the engine overheats, the system prompts the user to turn off the engine within a stipulated time, which is around 60 seconds. And note that this is not an actual count of 60 seconds. I made each count 1 millisecond lower so I could allocate the rest of the time to the other operations, making it a total of 63 seconds. If the user fails to turn off the engine within the stipulated time, then the system will automatically turn off the engine. And that's it. The engine just got turned off. Now you can start the car once the temperature has been reduced, which will be around 20 to 30 minutes, depending on the environment and several factors. If the temperature has been partially reduced, the system will return back to its cooling. Let's raise the temperature with my body temperature. Um, Not enough, I guess. Let's go with the hair dryer. Here we go. Suppose if the temperature sensor has malfunctioned or has been disconnected in the middle of the crisis, the countdown for the shutdown will not be disrupted in any way. A pull-up resistor is needed for the DS18B20 to work accurately because it may create an output signal by pulling the output line down to ground and allowing them to float. I'm using an NPN transistor to control the fan via external power supply. If I connected the fan directly to the Arduino Nano, then I wouldn't have enough current to make the sensor or the display work. The Arduino's voltage input is connected to the relay, so if the engine overheats, the Arduino tells the relay to cut off the power supply. Then the Arduino and the whole system shuts down. Thanks for watching. See you on the next video. Bye bye.